Now the mixing console, or mixer for short, is the control center of your band's sound. Its purpose is to provide the user with total capability to control the volume and tone of all the band's instruments and microphones. Additionally, it also allows you to blend signals and to route them to adjunct equipment so you can add effects or make a recording, for instance. You can manipulate your sound virtually any way you want. The ultimate objective is to take several different sonic inputs, extract the best qualities of all of them, and create a desired mix. Mixers come in all sizes when it comes to how many separate inputs or channels they can handle. Interestingly though, they almost always come in multiples of 4 channels. This particular Behringer stereo mixer has 32 channels and 8 buses. But what does that all mean? If you're new to all this, a mixer can be an intimidating thing. They can have literally hundreds of knobs and controls, but regardless of this, they're actually kind of simple. Now, all manufacturers put their own spin on things, and some have features that others don't have. The important thing to realize is that they're all on a logical level pretty much the same. Now, there are going to be people out there that tell you something different than I'm telling you. The beauty of working with a mixer is the incredible flexibility it provides you. You can do the same things many different ways. In fact, sound engineers, in addition to being technical people, are actually more like artists. You can have the best gear in the world and still sound really bad. A great artist of an engineer can take mediocre equipment and make you sound great. We're not here to make you into a great engineer. We're here to help you understand how to spend more time concentrating on your sound than reading manuals. You're the one who will have to experiment to see what works best for you. Each mixer has a few distinct operational sections that, once understood, will allow you to manage your sound and develop a little of that artistry. To cut through all of this mystery, we're going to examine these various operational sections and peel back what they actually do. The first operational area that's important is the channel strip. As you can see, the channel strip itself has several controls. They're arranged in a logical order and are dealt with from the top of the channel strip to the bottom. On many mixers, including this Behringer mixer, the controls for the various functions are color-coded to help you see the difference between the functions, as well as to prevent you from accidentally turning the wrong one and messing up all the settings while the band is playing. The individual channel strips are just replicated as many times as there are channels on the mixer. I bet you've probably seen some of those how-to home improvement TV shows where they tell you to measure twice and cut once. Well, the same kind of applies here. My advice when twisting knobs and changing settings on your mixer is to think twice and twist once. At least make sure you remember where the control was set in case you have to go back to that setting quickly. Okay, let's get started. Again, each manufacturer employs little nuances with regard to their mixer's capabilities. However, most generally utilize this accepted order of controls. Each of the channel strips coincides with a particular input device that you're trying to manage. Usually these are microphones, instruments, samplers, stuff like that. The first task is making certain that the device is plugged into the correct input jack. We'll cover these input jacks in a little bit. After that's accomplished, we need to ensure that the mixer is set to allow the maximum signal strength possible into the mixer without it being so loud that it distorts or clips. Distortion and/or clipping occurs when the signal strength exceeds the limit of 0 on a VU meter. 0 is the point in the signal strength where that signal strength exceeds the tolerances of the equipment and it begins to break up, thus losing its integrity, overloading, and possibly damaging the mixer as well as any downstream gear. In the analog world, distortion occurs. Now, I understand that distortion in terms of, say, a guitar amplifier can be a great thing. I'm not talking about that here. Those amplifiers are designed to allow you to manage the desirable aspects of distortion. I'm talking about the point where the sound coming out of the mixer will not resemble the sound that went in. I'm sure you've played your stereo too loud and the speakers have buzzed and everything sounded horrible. Well, that's distortion. Most equipment is made with some of what is termed headroom. That's where you see the VU meter reaching 0, but you actually have about 3% before everything really goes bad. You can still listen if you want, even if everything is distorted. In the digital world, once the signal exceeds 0 dB on the VU meter, it's referred to as clipping. All the parts of the signal that exceeded 0 are just gone. They've been clipped off. No 3% headroom, nothing. Now, many manufacturers of digital recording gear, for instance, know that your average user isn't going to be a professional engineer and they're probably going to blow through 0 on the meter all the time. So they program their VU meters to tell you you're at 0 when you're really not quite there yet. The best practice, however, is to make sure the signal level remains at a little below 0 and only reaches or exceeds it in very brief peaks. That's why the first control in the channel strip is the gain control. The gain control allows you to set the incoming signal level to its highest possible setting without overloading the equipment and causing distortion. This adjustment is made with the help of the peak indicator, which is a small light towards the bottom of the channel strip. During your band's sound check before the show, while the singer or musician is playing, the level of the gain control is increased until the peak indicator begins to very occasionally flash on. Once that point is reached, it's a good idea to back it off a little because no one, in my experience, plays as loud during the sound check as they do during the performance. Please note that once the gain control is set properly, it has nothing at all to do with the volume of sound that your audience will eventually hear from your PA system. That determination is made farther down the line. Once the gain control is set properly, we proceed to the next series of controls, which happen to be the equalizer or EQ controls. These controls are referred to as parametric EQ controls. They allow you to adjust the strength of entire frequency bands of the incoming signal to suit your taste. There are 3 or 4 controls depending upon the mixer's design, each one allowing the adjustment of a particular frequency range. They're usually divided into lows, mids, and highs. If you think the singer's voice sounds a little too bassy, you can increase the mids or highs. Usually each control is set to a flat response when it is set to straight up. That means that the signal is being passed through it without having any of the frequency ranges increased or decreased. If you feel the signal needs to have its frequencies adjusted, it's usually best to try decreasing the offending frequency range rather than increasing the others to overcome it. In other words, if you think the singer sounds too bassy, try decreasing the lows first rather than increasing the mids or highs. Each time you make a change to an EQ setting, you'll probably need to go back and reset the gain control to make sure that you haven't added or removed too much of the signal.